Hello everyone. Today I'll be presenting my Introduction to Data Science final project, which is the analysis of my chess games on lichess.org. So let's get started. I'm a freshman at Tobetu AI Engineering. So about the project, since 2020 I played over 6.5 thousand chess games, and I thought it would be insightful to analyze these games in order to improve my future gameplay. The data is collected by myself, playing chess on lichess.org for more than 5 years. These games can be downloaded as PGN files, which we will come to that later, what PGN is. What is lichess.org? So Lichess is an online chess platform where players can match with others in chess events from all around the world. Each player has a significant point, which could be, in other words, said as ELO, which increases on each win and decreases on each loss. And there is a time constraint on these games as well. Here's an example of the lichess.org homepage. Now, there are some summations on these games, as you can see, and I'll explain them to you right now. The left side element in these summations means the initial time both players have in the starting of the game, and the element in the left-hand side means the additional time added to your clock on each move you make. It is important for you to understand this part since I have an analysis on here especially. So, how did I extract the data? All these games you play on lichess.org can be downloaded as PGN files, which is the abbreviation for Portable Game Notation. These files include various information about the chess games like the usernames and ELOs of the rivals, moves, game date and time. Here's an example of a PGN file here. The event, the site, the date of the game, the nicknames of the white and black players, the result, the time, date, ELOs, everything properly. And these are the moves in the top. Okay. There are some previous activity about this topic. A Reddit user has made a similar project analyzing the chess games of the username given. The algorithm basically collects data about the frequency of the openings the player has chosen to play. As you can see here, there's a bar chart of the frequencies. How much of a fight the user puts up when losing, how many moves the lost games of the players has lasted, and the rating progress of the user throughout the years. So, how is mine different? My project focuses solely on my games, and it is further focused on the relational variables that rather than giving data as output, which we will see in a minute. Here are my research questions. Does my opponent's ELO influence my win rate? And at which time of day do I have a higher win rate? And do I tend to make more mistakes as my time goes shorter on my clock? So let's see how I analyze these questions and how I answered them. Here are my hypotheses in these questions. I think I would obtain a lower win percentage as the ELO difference between me and my opponents increase. And I think I would have more wins in daytime. And I think I would tend to make more mistaken moves as my time gets shorter. So in my findings, I compared the relevant variables to the topic in order to achieve results. My hypotheses have been corrected mostly. Most of them had been corrected with some changes. I used Pandas Lab for framing the relevant data and Matplot library for visualization of the results. So here's my analysis on the first question. Do I get more win rate in daytime? In the pie chart on the right side, you see the distribution of the chess games I play by the time of day. As you can see here, I play most of my games in the morning with a 62% and the least games at night with a 4.6%. And at the bar chart here, you can see my win rate by time of day. And at morning, I have a slightly higher win percentage. So we can say that looking at this data, since I play most of my games in the morning and have a higher win percentage, I would have a better chance at increasing my elo when I play my games at the morning. But it has a small effect, I can say, since the win rate doesn't change that much. Moving on, in this chart here, I analyzed mine and my opponent's elos throughout all my games. The yellow line in this graph shows my elo, and the blue dots show my opponent's elo in all my matches. Now here is an interesting result showing plain as day that my win rate drops as my opponent's elo increases. I segmented my games into 5 fractions with the elo difference, according to the elo difference between me and my opponent. In the games where I had more than 150 elos higher than my opponents, I had more than 70% win rate, which is stunning. And when I'm still higher than my opponents, but the difference is between 50 to 150, the win rate is still higher than 50%, and it drops down to 55% accordingly. And when I'm really close to my opponents, plus or minus 50 elo difference, it is close to 50%, which shows the success of lichess.org in matchmaking. It matches you with the players just as good performance as you. And when my opponents were greater than me, when I'm down 50 to 150 elos, my win rate drops to about 45%. And when my opponents are higher than 150 or more elos than me, it drops all the way down to less than 20%. This bar chart shows plain as day that the opponent's elo influences my win rate accordingly. So, moving on, I analyzed my mistakes and blunders, which are really bad mistakes. My hardware wasn't sufficient to create all 6,500 games analysis, so instead this data is collected from another file consisting of 18 of my latest games with the evaluation of each game. So, in these 18 games, I made a total of 478 moves, 9 mistakes, and 21 blunders. As you can see here, there's a pie chart I added with mistakes having 2% of my moves and blunders having 4.5% of my moves. So, this is interesting to see. When I compared my blunders and mistakes to the time I had on my clock, there was a stunning 100% data showing that all my mistakes and blunders were made when I had less than 20 seconds in my clock, which shows that I tend to make more mistakes when I have less time on my clock, as you can see here. So, can these findings be generalized? In my opinion, the first and third findings could be generalized for all players because as the opponent's elo increases, the accuracy they show in their moves increase as well, and hence causes them to harder to beat. And as the time in your clock gets shorter, you tend to get panicked and make mistaken moves and lose. So, the restrictions in my project were I only analyzed fast-paced games where players had 3 minutes on their clocks. Are the findings any similar or different to the previous activities? In previous studies, it has been shown that the accuracy of the player drops as his time gets shorter. There's an article about this topic in lichess.org website. And this project can be extended further in which other players' games can be analyzed as well. This could be more generalized maybe. Moving on, here are my codes. So I had 3 packages in total, analyzing every single question on their own. The dates package analyzing the win rate change by the time games occurred in the day. The ELOs package analyzing my ELO progress over time and win rate change by opponent's ELO, and the moves package analyzing my mistakes and blunders and their correlation with my remaining time. And as you can see here, I have the files I collected and extracted data from, and the overall win rate percentage calculator as a warm-up work. Let me show them through my project here. So, as a warm-up, let's see how I extracted my win rate from the games I played. This games.pgn file has all 6,500 games data, and in each question I need some of them, so I organized the data through my needings. First of all, we open the file and iterate it once to see if I lost or won. Basically, I did the similar activity in this file in the rest of the work as well. So, the current line is lines I, and the preceding line is lines I plus 1, and the second preceding line is lines I plus 2. If the current line starts with white, my nickname in the games file, as you can see here, let's give an example where I play white. Yes, like this line, and the result is 0 to 1. Count this game as a lose, and if it's 1 to 0, count this game as a win, and it's 1.2 or 1.2, count this as a tie. This basically has a looks through all the cases according to if I'm black or white, which was really algorithmic and fun to do. And when I run this code, we can see that I played a total games of 6.5 thousand. I had 3,000 wins, 3,000 losses, 200 ties, and a 48% win rate. So, in the dates file, first of all, I organized the data I needed to see the dates of the games and who won. When I work this, it creates a dates organized file, which only extracts the data of game times organized, okay, as you can see here, which only extracts these lines from games. Now, white player, black player, the result, and the UTCT time. From all these games here, it extracts these 4 lines and puts them onto this file. And these codes read those files and create pie charts accordingly. Yes, as you can see here, this code creates the bar chart of my win rates according to the time of day, and this creates a pie chart of the percentage of games played in several daytimes. Okay. In the ELOs package, there is also an organizer code, which only organizes the white, black, the ELOs, and the results parts of the games. Now, if I run this creates another file which is ELOs organized. Now, this extracts the data of white player, black player, the result, and the ELOs of the rivals. And the other codes in this reads this file and create pie charts and bar charts. So, win rate by ELO diff chart creates this bar chart which we showed before, and the opponent ELO chart shows the line graph Okay, moving on, last but not least, we have the moves file analyzing my mistakes. So this code creates this chessmoves.csv file, which has my moves, game number, the time remaining on my clock, and the evaluation after each move I played, the evaluation change after the move, and the player color. The way of how I extracted my mistakes and blunders is according to the evaluation change, which gives plain data of if that move was a mistake. If your score decreased dramatically after you played the move, that means it is a blunder or a mistake. So I iterated through this file and searched if the evaluation change was between -1.5 or 2.5. If it was, it counted that move as a mistake, and if the evaluation change was lower than 2.5, it counted it as a blunder. So that was all from me, guys. I hope you enjoyed this. It was really fun and teaching to do. See you in the later videos. Goodbye.